Did you used to make sandcastles at the beach when you were little? The structure had a moat, so you needed to dig deep. While holding a plastic shovel, you probably thought, how deep can I go? Well, this question motivated a group of scientists in the Far East. They have decided to dig the deepest hole in their home country, China. The drilling team's goal is to reach a depth of nearly 33,000 feet. That's about 1 1/10 times as deep as Mount Everest is tall. The location of the borehole is at the edge of the second largest shifting sand desert in the world, Taklamakan Desert. During a single day, air temperatures there can vary over 100 degrees. The drilling rig is impressive on its own. It weighs some 550 tons and is the height of a 20-story building. And it's pretty powerful, too. It can lift the equivalent of 120 adult elephants. These engineers aren't kidding. One of them compared the project to driving a big truck on 2 thin steel cables. That's why they expect the dig to last well over a year. Their ultimate goal is to drill downward through 10 layers of strata. These are horizontal layers of sedimentary rock. Sounds complicated? Just look at any exposed cliff and you'll notice how it has stripes of different colors. These are the strata I'm talking about. If we translate it from Latin to plain English, we'll get things that spread out. Makes sense. Each layer of rock represents a specific geological period. Remember Spielberg's 1993 blockbuster Jurassic Park? That's just one of these geological periods. It ended some 145 million years ago. But in Central Asia, scientists won't travel that far through time. They hope to reach the rock dating back to the Cretaceous. That's the geological period just after the Jurassic. It lasted until some 66 million years ago. This was the time when T-Rex still roamed North America. But why mount such a complicated operation in the first place? A single goal would be a waste of funds. That's why engineers in Central Asia have several objectives. They want to explore the planet's internal structure. This involves the search for natural resources, such as mineral deposits and oil. Another goal is to collect scientific data on earthquakes and volcanic eruptions. The information will help researchers better predict these events in the future. So, hardcore science is behind this pioneering project, but it's not the first of its kind. Deep in the Arctic Circle lies the Kola Peninsula. And no, it doesn't have anything to do with the famous beverage company from Atlanta. This Kola is a region of great natural beauty, covered in forests and lakes, and an abandoned scientific research station. Inside this crumbling building, a rusty metal cap sticks out from the concrete. It doesn't look that impressive today, but this is the site of the deepest man-made hole on the planet. It is over 40,000 feet deep. That's deeper than the Mariana Trench, 36,201 feet, the deepest place on Earth. Scientists were drilling it for nearly a quarter of a century. The project started in 1970 and finally shut down in 1995. But if you travel to this region close to Norway, you wouldn't be impressed by the shaft. It is only 9 inches in diameter. It would be impossible to fall down such a narrow opening. And despite the figures, the hole is pretty shallow on a bigger scale. You see, the drill bit went through only a third of the Earth's crust. Let me explain. Remember those layers of strata? Yup, that's what our planet looks like on the inside. The 3 layers are the crust, the mantle, and the core. The crust accounts for only 1% of Earth's mass, and it's some 25 miles thick. But it holds nearly all life in the known universe. The deeper you go, the hotter it gets. At the place where the crust meets the mantle, Moho, temperatures max out at 752 degrees Fahrenheit. Ouch. There are 2 types of Earth's outermost shell, oceanic and continental. The crust is thinner under the ocean floor, so why not drill here? Well, the thinnest part is usually the deepest part of the ocean. That doesn't mean that people haven't tried to drill into the seabed. Americans attempted this off the coast of Mexico in 1961, Project Mojole. Drilling underwater was more expensive than anyone anticipated. A few meters of basalt, the researchers were able to bring up costs some $40 million in today's money. Not worth the effort, literally. The Kola Superdeep borehole also burned money quickly. And that wasn't the only heat scientists had to face. The temperature at the top depth was a staggering 356 degrees Fahrenheit. That was double what the drilling team expected. Their machinery simply couldn't operate in that heat. At this depth, rocks behaved more like plastic than rock. If they had gone deeper, the stones would have the consistency of oversized caramels, but the drilling team gave their best. They even invented a new type of drill where only the tip rotated. There was also a lubricant to smoothen the process. This simply means they pumped a lot of pressured mud into the hole. Yet, they came short. Have scientists completely given up? Not by a long shot. The Japanese built a ship, Chikyu, 20 years ago to drill through the seabed, and they have invested a hefty sum in the project, $1 billion. The mission's goal was to drill into the Earth's crust where it's the thinnest. Under the ocean floor, it is less than 4 miles thick. If the Japanese team of scientists succeeds, it will be the first time humans recovered in situ mantle rocks. What is that? In situ is a Latin term that simply means in the original place. The only time we get to see what Earth's mantle looks like is during a volcanic eruption. A plume of hot mantle rising to the surface will form a volcano. You know the rest. But where are the Japanese researchers planning to drill? After all, they have a huge ship, so it could be anywhere in Earth's oceans. They've narrowed it down to 3 locations: Costa Rica, Hawaii, or Baja. In cartoons, characters often dig up a hole and end up in another country. The idea is that since our blue planet is round and you dig straight down, you'll end up on the other side of the world. Sounds interesting, but this theory has no grounding in truth, pun intended. Science knows more about outer space than about what's underneath our feet, and digging won't get us far. The temperature at our planet's inner core exceeds 10,000 degrees Fahrenheit. The best heat-resistant materials humankind has developed, tantalum carbide and hafnium carbide, can withstand around 7,000 degrees Fahrenheit. Good enough for building spacecraft, but not good enough for traveling to the center of our planet. But will Jules Verne's famous novel, Journey to the Center of the Earth, ever become a reality? For now, we can only imagine. The vessel that would take someone to the center of the Earth would first have to have great insulation. Then it would have to withstand a pressure 4,000 times stronger than at sea level. Let's talk about the finances. The cost of this imaginary mission would be astronomical. The good news is that you could pay it off with what you find underground. At a certain depth, 93 miles, you'll stumble upon diamonds. They form when all that heat and pressure alter the structure of carbon atoms. The final leg of the journey would take you through the Earth's core. The temperature here is the same as on the surface of the sun, and you'd be traveling through molten iron and nickel. But that's not the weirdest fact. The outer core has low gravity. The mass of our planet would be behind you. So the gravitational force would actually pull your vessel backward. Future travelers to the center of the Earth better have a supercharge button. That would be the only way to reach the planet's inner core.
See this? You're looking at the best full portrait of the Sun by far. Thankfully, our 4.5-billion-year-old parent star didn't use any makeup to fix its skin tone before this photo shoot. And now we can study its surface in great detail. This iconic image was taken in March 2022. NASA wanted to gain a better understanding of solar behavior and its impact on life on Earth, and the future of our space technologies, of course. To do so, they launched the Solar Dynamics Observatory Satellite, or SDO, mission in February 2010. This legendary photo shoot happened 12 years later, when SDO was halfway between the Earth and the Sun. Scientists had to assemble 25 individual images like a puzzle. So the final image contains 83 million pixels. Yeah, the resolution is about 10 times better than your fancy 4K TV screen. Look at this amazing cookie-like pattern. Typically, the bright surface of the Sun overshadows it when we observe the star from Earth. Thankfully, NASA explored the light beyond the visible range, which allowed them to discover some invisible details of the Sun's face. When you adjust your selfie with filters and effects, you can end up with completely different portraits, highlighting different spots of your face, even those you didn't know existed. The same principle works here. All these plasma balls are the same photo of the Sun, captured at different electromagnetic wavelengths. The revealed spots and patterns can help us understand events happening inside the Sun's skin a little better. At the speed of light is supposed to mean super quick. But this rose gold ray caressing your cheek at dawn has come a long way and is incredibly old in human terms. Photons generated by the Sun's core take between 10,000 to 170,000 years to travel through the star's atmosphere, and then around 8 minutes more to reach Earth. So let's explore what's taking them so long. Our tour begins with the upper layer of the Sun's atmosphere. Remember solar deities in movies and theater plays? They often wear luxurious crowns with golden rays. Well, the real Sun does wear a fancy corona too, which is the outer layer of its atmosphere. But of course, its size and glory are incomparable with those plastic costume crowns. And its shape is not so stable. Corona is a gas shell enveloping our parent star, so its size and form constantly fluctuate under the influence of the Sun's magnetic field. You can spot this crown with the naked eye from Earth during total solar eclipses. It looks like a beautiful, intense radiation around the solar disk, which itself is completely blocked by the Moon. The corona stretches 5 million miles above the Sun's surface, whereas our blue planet is only about 8,000 miles in diameter. So, one hypothetical ray of the corona equals a row of about 625,000 Earth-sized planets. And suddenly, all my problems begin to seem tiny. Now here's another fun fact. The Sun's corona kind of breaks the laws of known physics because it's hotter than it should be. Its temperature reaches 2 million degrees Fahrenheit, whereas the surface of the Sun is only about 9,000 degrees. Although the word "only" doesn't fit here, because it's still super warm in human terms. Usually temperature tends to fall as you move farther from a heat source, but it's not the case here. Space scientists are still scratching their heads trying to investigate this mystery. Thankfully, the recent photo shoot allows us to explore what's going on inside this massive hot stuff without risking losing our sight. Take these beautiful bright spots, for example. They depict solar flares happening under the corona layer. Solar flares are powerful explosions that happen when magnetic fields bump into each other. When it happens, they change shape and quickly reorganize. These fields arise from plasma, which is very turbulent itself, so these events are no surprise for the local weather. Now, who would have thought that the Sun has dark spots on its skin, just like people? These darker areas are known as coronal holes. Earthlings can experience their impact when they observe the beautiful aurora lights in the polar regions. Coronal holes look darker because plasma in these spots is cooler, less dense, and magnetically open. These conditions allow the solar winds to escape outward across the solar system rather than hang out at the Sun's surface. And when they bump into the Earth's magnetosphere, auroras emerge to fascinate our eyes. Thankfully, the local fields cool down the solar winds. Nobody wants their eyes to melt, right? Now, if we were looking for an analogy to the Sun's hairs, the best candidate would be solar prominences. These large, bright plasma loops arise from the Sun's surface and stretch for thousands of miles into space. Their lifespan varies from days to several months. It's one of the most common events in this region. Although the first detailed description of solar prominence dates to the 14th century, modern scientists are still researching how and why they're formed. Diving further inwards, we're facing the transition region. The thickness of this layer is about 62 miles, and the local weather is unthinkable. Temperatures can rise up to 900,000 degrees Fahrenheit. The transition layer sits between the corona and the last region of the Sun's atmosphere called the chromosphere. Now, speaking of which, welcome to our next stop. The chromosphere region is famous for a scientific mystery called a spicule. Come on, say it with me. Spicule. That's fun. These spectacular grassy-like jets of plasma fire upwards from the surface of the Sun and reach speeds of approximately 224 miles per second, as if they're jumping on a trampoline from the surface of the Sun. Each spicule lasts for just a few minutes in outer space before falling back into the solar atmosphere. Astronauts were having a challenging time trying to explain how magnetically charged particles could manage to escape the massive gravity of the Sun while being so close to it. The possible answer emerged in 2017. A group of scientists discovered that neutral particles provided the magnetically charged particles with extra buoyancy to escape the solar gravity for a while, which is better than my cousin's explanation, which is happy thoughts and pixie dust. Yeah. Now let's go ahead and travel 1,000 miles inward toward the chromosphere to finally reach the solar surface, the photosphere. It's around 248 miles thick. But unlike planet Earth, the Sun's surface is not solid or stable at all. The temperatures here are insanely hot for any matter to exist. On the other hand, scientists often call plasma the fourth state of matter. And why not? It's made of ionized atoms and free electrons, so it kind of deserves to matter. So what's the matter? Maybe someday we'll happen to meet the local civilization of plasmoid people, but I think it's best that we skip their welcoming warm hugs. You know, hot, hot, hot. Anyway, the photosphere is our final stop, because humankind doesn't have the technology to explore the sun any deeper. So if you want to learn more, you'll have to invent your own spacecraft. But time's a-wasting. You'll only have about 7 to 8 billion years. After that, our sun will fade away, according to scientists' estimates. Actually, those same scientists will be going first. Now, you have a serious competitor, though. NASA's Parker Solar Probe is the current champion for the deepest dive into the sun. The spacecraft managed to travel 4.5 million miles from the sun's surface toward its core on September 27, 2023. And then, the Parker probe repeated its own record once again in December of the same year. So, why didn't it melt, I hear you asking? The probe has been designed to withstand insanely intense conditions and temperature fluctuations. It's equipped with a custom heat shield and an autonomous system protecting the mission from the massive solar lights. NASA has further ambitious plans. In December 2024, Parker will make its closest approach to the Sun. It will travel faster than any man-made object has ever traveled, at the speed of 435,000 miles per hour. The probe will be just 3.8 million miles away from the Sun's glowing hot surface. It's like landing on a star. Astronomers have already compared this epic upcoming milestone with the moon landing. I'm thinking, however, it might be safer if we, landed at night. Yeah, you're right, that's an old... You're standing on the bow of the ship, admiring huge waves, and trying not to stare at that kraken over there. Nah, just kidding. You're in luck, and today you'll be part of a marine expedition exploring the deepest parts of the world's oceans. You'll start with the Indian Ocean. The Sunda Trench. It appeared here because of the movement of tectonic plates. Those are huge chunks of land that float on the ocean of lava deep beneath the surface. Tectonic plates are like jigsaw puzzles that cover the whole surface of our planet, and they move all the time. When two puzzle pieces collide with each other, one of them eventually goes under the other. The tectonic plate underneath starts to bend, it goes down, and water fills the void. Many years after this happened in the Indian Ocean, there's a nearly 24,000 feet deep trench in that place. It's like 24 Empire State Buildings stacked one on top of each other. This trench is so deep that the technology didn't allow people to send a crewed submarine there until 2019. Research has confirmed that the Sunda Trench is the deepest point in the Indian Ocean. The constant movement of tectonic plates in that region causes tsunamis with high waves and earthquakes of magnitude even greater than 8. Scientists also believe they might have discovered life forms that have never been known to science before. Those are new species of snailfish and ascidians. This last one is a living organism that looks like a small bag. Put on a warm jacket, you're heading north. About 100 miles away from Svalbard, a Norwegian archipelago, there's the deepest point of the Arctic Ocean, the Malloy Hole. The first and only man to descend there used a $50 million submarine. He descended to a depth of more than 18,200 feet. This is the height of the mountains in Bhutan in South Asia. Previously, this place was only explored with the help of sonar. A ship with special equipment stopped right above the trench and sent sound waves downward. These waves bounced off the ocean floor and returned to the ship. After analyzing how fast the wave traveled through the water and the time it took for it to return to the ship, scientists managed to calculate the approximate depth of the Malloy Hole. To determine the real depth more precisely, the researchers measured the pressure at the bottom. At the surface, it's 1 atmosphere. 30 feet underwater, the pressure doubles. At the very bottom of the Malloy Hole, the water pressure is 1,110 times greater than that at the surface. The South Sandwich Trench. This one was created by the collision of the South American Plate and the South Sandwich Plate. A volcanic arch also appeared there. That's a chain of islands with high volcanic activity. Lava rushed out of the volcano and cooled when it touched water. It resulted in the appearance of new islands. On one of them, there's Mount Belinda. It's still an active volcano. Researchers kept exploring the trench with sonars until they found its deepest point at almost 27,000 feet. That's nearly 35 times deeper than the record depth for freediving. The leader of the expedition descended to that depth in a DSV limiting factor submarine. The deepest point in the Atlantic Ocean is near Puerto Rico. It's the Milwaukee Deep. The first crewed vessel descended there in 1964. The French submarine Archimedes managed to reach a depth of 27,200 feet. That's like 10 Burj Khalifas, which is the tallest building on Earth, stacked on top of one another. But the submarine never reached the bottom. More than 50 years later, a new expedition finally got to the bottom. It was 280 feet below the previous mark. This means the first expedition stopped only one soccer field away from their goal. The modern crewed submarine limiting factor set the record for the deepest dive, 27,480 feet. By comparison, the record for a scuba diver is only 1,089 feet. And the atmospheric diving suit, which looks like a small human-shaped submarine, allows you to get down to a maximum of 2,000 feet. The Kuril-Kamchatka Trench is one of the deepest places in the Pacific Ocean. It's also one of the oldest. It was formed about 66 million years ago when two tectonic plates collided with each other. As a result, the Kuril Islands and Kamchatka volcanic arc appeared here. This is the region of some of the most severe earthquakes on our planet. The deepest point of the Kuril-Kamchatka Trench lies at about 34,500 feet below the surface, and it's so wide that the whole Manhattan Island could fit there, twice. When two giant tectonic plates collided, several more trenches appeared in this region. For example, the Japan Trench. This is a continuation of the Kuril-Kamchatka Trench. In 1989, the first expedition visited this place. 3 researchers on the submarine Shinkai 6500 managed to descend to a depth of 21,410 feet. That's like 21 Eiffel Towers on top of one another. In 2008, another expedition reached a depth of more than 25,200 feet. They discovered life there and even managed to film a group of Hadal snailfish swimming by. These creatures were as long as a big banana. Another trench in this chain is the Izu-Ogasawara Trench. Its maximum depth is about 32,100 feet. It's as great as the height of 72 London Eyes. In this trench, scientists discovered xenophyophores at a depth of 4 miles. These things that look like loofahs are actually living organisms that consist of only one cell. They can withstand extremely low temperatures and tremendous pressure. A pillar of water presses on these organisms with a force of 8 tons per square inch. You can compare it with a large truck parked on a matchbox. Sunlight doesn't reach these depths, and these little guys get all their energy from filtering water. The next stop is the Tonga Trench. This is the second deepest place on our planet, 35,500 feet. By comparison, the Olympic running track is 1,310 feet. You'd have to run 27 laps to get to the very bottom of the trench, the horizon deep. And still, there's life in this dark and cold place. Researchers have found several communities of nematodes there. These are roundworms that are even shorter than the eye of a needle. In the trench, there's also a strange object that got there from space. In 1970, an oxygen tank from one of the rockets that flew to the moon fell in this area. It sank somewhere in the depths of the Tonga Trench. The Serena Deep is right next to the Mariana Trench, and it's almost as deep. In May 2019, 2 explorers reached the bottom of the trench, 35,150 feet below the surface. Planes fly above the ground at the same altitude. The explorers spent nearly 3 hours in the Serena Deep. They took many videos and collected biological and geological samples. The team managed to get their hands on a piece of the deepest mantle rock in history. Now, you've arrived at the deepest place on the planet, the Mariana Trench. Let's dive in. You've descended more than 36,000 feet. Your destination is the Challenger Deep. The pressure there can crush an ordinary submarine with the ease of a truck running over a bag of chips. If you shoved Mount Everest into the Mariana Trench, the mountain's peak would still be hiding underwater. People first visited this place in 1960. At the bottom of the trench, researchers found some flat fish that looked like a flounder. It was clear that living organisms there had adapted to the extreme pressure and darkness at such depth. It resulted in fish being very small. There's almost no food in the trench. All they can munch on is some plankton and fish scales getting there from the upper layers of the ocean. After a Japanese probe took samples in the Mariana Trench, scientists discovered some other life forms. Those were foraminifera, single-celled organisms covered with something resembling a shell. An American filmmaker visited the trench in 2012. He used a single-seater bathyscaphe with a lot of research equipment, 3D cameras, and powerful lights. The intense pressure down there damaged some of the batteries and lights. But the man made it to the surface and brought back plenty of soil and water samples, as well as beautiful footage from the bottom of the Mariana Trench. In 2019, an explorer who had visited the deepest places of all the oceans on Earth set a new world record here, 35,853 feet. He became the first person in history to have been to the highest point on the planet, Mount Everest, and the deepest one, the Challenger Deep. He later piloted a deep-sea submarine to take scientists to that depth. A total of 16 people have been there by now. For comparison, 574 people have already been to space. And now, a bonus fact for you. The deepest hole people have ever drilled is the Kola Super Deep Borehole. It's 7.6 miles deep. That's like 6.5 Brooklyn bridges. Legends say the borehole produces strange sounds, but no one knows for sure if it's true.
If one of the many apocalyptic scenarios come true and humanity is wiped out completely, a black box will tell whoever comes after us about what has led to that scary day. The 33-foot-long vault in a remote part of western Tasmania is supposed to document all the mistakes humanity has made that led to an apocalypse. The artists, architects, and researchers behind the Earth's black box hope that the art installation made of thick, reinforced steel will withstand fire, water, and any other natural disasters, except probably for total planetary destruction. Just like the black box you can find in planes, this time capsule is supposed to help the next civilization do better and avoid the probable sad and tragic fate of our humanity. The project is fully non-commercial and has an important message. The box will be full of storage drives and have access to the internet. Solar panels on the roof will power it, and batteries will take care of backup power storage. Whenever the sun's out, the black box will be updating itself with new scientific data. A special algorithm will sort it only to save the information relevant to the project. It will be measurements of land and sea temperatures, ocean acidification, species extinction, land use changes, as well as data on human population and energy consumption. The second type of data for the box will be newspaper headlines, social media posts, and news from the key global events focusing on the environment. The creators of the box decided to encode and store data for it in several formats, including binary code. The instructions on how to retrieve all that priceless knowledge would be etched into the outside of the box. Some of the big brains involved in the project are afraid that this could inspire some curious bad guys to break into the box long before it's time to do it. The solar-powered hard drive will have enough space to collect data over 50 years. Even the most pessimistic scientific models don't predict the end of the world any sooner anyway. It might even take centuries before the worst happens. The idea of a box that would record everything that happened before an accident in aviation was born in the middle of the 20th century. Back then, the world's first jetliner, de Havilland's Comet, crashed 7 times over 2 years, taking the lives of 110 people. The Department of Civil Aviation in Australia wanted to find the possible cause of all these crashes. One of these experts was Dr. David Warren, a chemist specializing in aviation fuels. He realized that there was simply not enough data to make any conclusions. There was no one to tell what had really happened before the crash. He remembered seeing a dictaphone that recorded sound on steel wire at a trade fair. Soon, Dr. Warren wrote a memo to his manager offering to design a voice recorder to follow what was going on in the cockpit. It would also record flight data and be stored in a crash-proof container. Flying wasn't a huge thing in Australia back then, so the manager didn't appreciate the idea. Dr. Warren then started working on a prototype in his own garage. He showed the ready device to the secretary of the British Air Registration Board when he was in Australia. He absolutely loved the idea, so later, Dr. Warren got a whole team to help him develop a pre-production prototype. The correct way to call his invention is actually not black box, but flight data recorder, and it's orange, not black. We probably call it black because those gadgets get charred black after a crash. Or maybe because the first boxes were painted that color to prevent reflection. Or because that's the general name scientists use for devices with in and output of data with complex internal workings. So, the flight data recorder consists of 2 parts: the data recorder and the cockpit voice recorder. Historically, they were 2 boxes, but now they're just 2 cylinders. The data recorder keeps track of such important flight data as engine exhaust, temperature, fuel flow, aircraft velocity, altitude, and rate of descent. The second part records sound in the cockpit to analyze communication with air traffic control in case of an accident. The device only records data for up to 2 hours and then overwrites the previous sounds. Sometimes, the 2 parts are combined and they look like a box. The devices record data and voices from the cockpit, but they are actually located in the tail end of the aircraft, where the structure of the plane will protect them best in case of a crash. The black box has a locator beacon, which is activated when water gets on it, but it will send out a pulse for 30 days. Search parties use the bright orange color of the recorder as a visual beacon. Sometimes, it takes a long time to find the box, and in some cases, they don't find it at all. Long before the first plane was invented, there was an original black box of planetary meaning, the ancient library of Alexandria. Back in the ancient days, people in places like Egypt, Mesopotamia, and Greece were no strangers to libraries and archives. But these early institutions were more about preserving local traditions and heritage. The whole concept of a universal library only became a thing when the Greeks started thinking big. They were so impressed by what their neighbors in Egypt were doing that they arranged expeditions to acquire knowledge. Alexander the Great, the king of Macedonia, seeing that hunger for knowledge required his companions, generals, and scholars to report to him in detail on regions that were previously unmapped. It helped collect plenty of information on geography and contributed to the creation of a great library. Most of the information it had was written in Greek. It had the books of Aristotle as part of the whole corpus of Greek literature. Some sources say that in the hunt for new books, the library's founders would stop every ship sailing into the harbor of Alexandria. If they found books, they would take them to the library. If they decided it was valuable, they'd make a quick copy and return it to the owner with some compensation, leaving the original at the library. Another story tells us that Ptolemy III, grandson of the founder of the library, offered the governors of Athens a huge compensation to copy the original texts of the greatest poets. He then kept the originals and sent them back copies. Once the Roman Empire arrived, they burnt all that knowledge, not thinking that it might lead to their own collapse. There was no easy way of spreading information across the world, so one source had most of the knowledge humanity had accumulated by then. The great minds of those times didn't just fill it with knowledge, but also made important connections, trying to make the best use of that information. If the Library of Alexandria hadn't burnt, we could have gotten some priceless knowledge about the people who had lived before the current era. Some scientists believe that big data could have saved the Vikings that had settled in Greenland many centuries ago. It might have also helped the Easter Island civilization to identify and address problems caused by volcanic activity, latitude, and rainfall patterns, and restore soil fertility. They say that a typical person living today is exposed to as much data in one day as someone in the 15th century would learn in their entire lifetime. And there's a theory that every papyrus scroll on the whole Library of Alexandria could probably fit onto an ordinary flash drive you have in your pocket. There's so much big data generated every day that it might do us more harm than good because of a huge information overload. We're moving towards a global civilization, so if all that knowledge disappears, we lose not one empire, but the entire world. In January 2022, a volcano eruption happened in the Tonga Islands that forever changed the way we understand GPS signals. This volcano caused a massive disturbance, sending out a colossal mix of gas and debris in the air. It generated a shockwave that traveled across the entire atmosphere, reaching all the way to Alaska, and launched a tsunami over nearby islands. Over northern Australia, it crafted a weird plasma bubble in the upper atmosphere, which disrupted GPS systems for hours. People that happened to be under this bubble and in need of precise GPS waited for ages before their device could receive precious information again. The exact place where these disturbances occurred is called the ionosphere. It's the place where our atmosphere meets outer space and looks like this buzzing layer where heat from the sun turns gases into electrically charged particles. It can also be seriously unpredictable, changing depending on the weather and thinning out when the sun's rays are less powerful. Because it's electrically charged, the ionosphere helps us with our communication needs. It houses many satellites, including the International Space Station. Here's how changes in the ionosphere can interact with GPS signals. Let's say you're playing detective with your friends and need to find them using a special radar. This radar sends out invisible waves through the ionosphere to locate your buddies. If everything is normal, you'll find their precise location in no time. Should those waves go through a place where the ionosphere particles are a bit messed up, the waves might slow down, get scattered, or change direction, confusing your radar. In the same way, when GPS signals travel through a damaged ionosphere, they can malfunction. Scientists have developed a way to fix this, like special sensors to anticipate changes in the atmosphere. The ionosphere is also sensitive to rockets being launched from Earth, not just storms and volcanoes. At first, astronomers believed these red patches they were noticing in the sky were similar to the northern lights found in Sweden, Finland, or Canada. But they soon figured out there were gaps in the ionosphere. Beautiful to look at, yes, but experts are worried that these crimson areas might be causing communication and astronomy problems that we've yet to discover. Since scientists don't know all the effects of these holes on our environment, it's best to steer clear if you see a red hole in the sky, just to be safe. But at least they seal up within 10 to 20 minutes. Mars has its own eerie set of lights happening in the atmosphere, and you'd think, since it's the red planet, these lights would also be red. Should you ever land on its surface, surprise! At times, the sky turns to a green glow. This unexpected hue could be very important for future Mars trips, since it can help specialists better understand the Martian atmosphere. Or what's left of it. That's because at some point in its history, Mars switched from being a warm and wet world to the cold, dry plains we know today. How is Mars slowly losing even what's left of its atmosphere? One popular theory is that Mars's weak gravity, combined with the fact that it doesn't have a strong magnetic field, lets the atmosphere escape into space. This vulnerability comes from the solar wind, a constant flow of particles from the sun. The sun's push over millions of years may have thinned out the atmosphere, grabbing the lighter parts. Some scientists suggest another possibility. A colossal impact by another object might have swiped Mars's atmosphere away. Studying this greenish glow is key to understanding what's going on the Martian atmosphere, a place satellites can't directly explore. Since we plan to visit this neighboring planet in the following decades, scientists intend to develop the perfect spacecraft. Knowing its atmospheric density helps us build machines tough enough to handle Martian drag, and we can design parachutes that gracefully descend to the Martian surface. See these amazing purples and greens lighting up the sky? That's not your typical aurora. It's Steve. First discovered by regular people, not scientists, some years back. We now know it's the aurora's more elusive cousin. Steve is short for Strong Thermal Emission Velocity Enhancement and was caught on camera back in 2018 by a bunch of amateur aurora chasers in Canada. They then brought it to the attention of NASA scientists. Here's how this is different from the aurora, starting with the appearance. Steve is more of a magenta streak, while the aurora is usually made out of green ribbons. Auroras happen when particles from the sun interact with the Earth's magnetic field and atmosphere, causing gases to emit light. Steve is thought to be a separate optical phenomenon that sometimes appears alongside auroras. While the exact mechanism behind it is still being studied, scientists believe it is linked with charged particles in the ionosphere that also interact with the Earth's magnetic field. Now that we know where to look, Steve might not be as rare. If you're planning to catch a glimpse of it, you'll need to travel to places where auroras usually happen, like Canada, Alaska, Northern Europe, New Zealand, and Australia. That's because it's never visible on its own. It's powered up when the aurora is extra bright during geomagnetic storms. Auroras can also happen on the sun too. These luxurious lights happen somewhere around 25,000 miles above a sunspot, a dark magnetic patch on the sun's surface. Astronomers have only recently discovered our own sun is capable of generating these lights. So far, they've only spotted aurora-like signals from faraway stars. Here on Earth, the aurora can last anywhere from 15 to 30 minutes, maybe even a couple of hours if you're lucky. On the surface of the sun, though, this phenomenon is a week-long display of intricate lights. Strange lights in the sky can also happen before an earthquake hits. Mexico had its share in 2017, lighting up the internet with pictures of weird celestial shades before a massive magnitude 8.1 earthquake. Some voices in the scientific community wonder if this light phenomenon is indeed connected to earthquakes at all. Others have this theory that such lights are caused by the release of ionized oxygen from the breaking of certain rocks. A photographer from Finland captured these shots of a circular rainbow display in the sky and wondered what might be causing it. It's something pretty ordinary: pollen. These colorful rings are called pollen coronas, and they happen when sunlight hits the pollen in the air at a certain angle. You can easily tell if you're looking at pollen coronas if they're accompanied by star-like sparkles. Those are individual pollen grains, and they come in many sizes. The process is very simple. Sunlight hits the pollen and scatters into different colors. Some colors get blocked or crash into each other, creating a pattern known as diffraction. The pollen in these images is from pine trees, and under a microscope, they look like tiny Mickey Mouses. Those ears are actually air pockets that help them float in the wind. The air sacs all line up in the same direction, creating the elliptical shape of the rings. For these coronas to show up, pollen levels need to be very high. An astronaut up on the International Space Station once snapped this picture of our planet, showing these two weird blue patches of light in our atmosphere. They might seem related to each other, but these lights are two different natural phenomena that just happen to be captured at the same time. The first one down at the bottom is a massive lightning strike that zapped somewhere in the Gulf of Thailand. Lightning is usually pretty hard to spot from way up there because of clouds, but this time it struck between them, firing up the walls around it like a luminous ring. The second blue blob up in the top right happened because of the moon. The way our natural satellite lines up with the space station lets the sunlight it reflects shoot straight through Earth's atmosphere. This turns it into a bright light with a fuzzy halo. It happens because some of the moonlight bounces off tiny particles in our atmosphere, making the moon look blue in this picture. That orange halo curving along Earth's edge is just the atmosphere. Nights can last 24 hours here. Streets have no names, and some say there are more polar bears than humans. Cats are also banned, and if you manage to get here, you'll be expected to take off your shoes when entering a restaurant or a museum. Svalbard is a group of Norwegian islands that lies in the chilling depths of the Arctic, and it's one of the closest places to the North Pole people can live in. Visiting needs a lot of planning in advance. You'll need a visa, clothes for extremely cold weather, and an experienced local expert to guide through the wilderness. Why no cats? Because they're considered an invasive species that can damage delicate wildlife, especially the birds, which have no idea how to fend for themselves against furry felines. There are no names for streets, only numbers. This was the custom way back when the region was filled with miners, and they wanted to keep things simple. You might see slippers being offered when you enter an establishment for people who want to take off their shoes. This is also based on an old practice when locals took off their dirty outdoor shoes to avoid making a mess inside. These islands are also home to the impenetrable global seed vault. The construction needs to be kept in pristine conditions, since it's home to around 1 million plant seed samples in case something bad ever happens to our planet and we need to rebuild our natural habitat. The plant vault was constructed deep within a mountain and over 400 feet above sea level. It's also built to withstand very strong earthquakes. There are no visitors allowed inside, but some guided tours take people very close to its gates. Once you reach this island in the South Pacific, you can claim a piece of land and start building your dream home. It's called Pitcairn, and last they checked, it hosted less than 50 permanent residents. The weather stays tropical all year round, and the landscape is breathtaking, but it's a pain getting there. Say you're departing from Los Angeles. You'll first need to take a flight to Tahiti. Then, board another flight to the island of Managriva, which only departs once a week. Here you'll reach the closest airport to Pitcairn, which is still 330 miles away from the shore. The rest of the adventure needs to be completed by boat, but it will take you more than 30 hours. That's only if you're lucky enough to embark in the first place, since the boat journeys to the island with supplies a mere once every 3 months. There's not a lot of things to do for such long travel times. Only 4 families live on the island, and there's a single cafe and 1 art gallery. You might be able to book a stay in a former prison, though. Locals first figured out they needed a prison in 2004, but it soon became unused. So now it also doubles as a hostel. Underneath the Bank of England, there's its mysterious gold vault, a fortress that's notoriously hard to explore, for good reason. It's said to house around 400,000 gold bars, valued at around $250 billion. There are many layers of defense on this place. Complex tech surveillance, heavy doors weighing over 3 tons, guards that are on alert 24/7, and the very few people authorized to reach past the gates use things like voice recognition to unlock. The official story back in the 1800s was that the bank had such a good defense that it could never be robbed. There is a rumor, though, that bank officials started getting anonymous letters claiming someone managed to pierce its walls. They shrugged it off until they met face to face with the culprit, a sneaky sewage worker. He slid out from under the floor of the vault, claiming he'd made his way in after discovering an old drain during repairs. An honest man, the sewage worker never touched a dime. To his surprise, he wasn't punished for breaking in. Legend has it he was rewarded with the equivalent of around $100,000 for discovering the security breach. This perky building is called the Trídongar Lighthouse, and it can be found in Chile, Iceland. This compact construction is perched on the highest of 3 rocky spots in a tiny cluster. Waves constantly crash against the cliff, which means it's not reachable by boat. The only way to get there these days is via helicopter. It's not open for tourists, but there are many nearby helicopter-guided tours that explore its surroundings. Constructing this sturdy building back in 1939 was tremendously complicated. The builders had to manually lay the foundation and climb nearby cliffs to hit the pinnacle. The tough weather with its freezing rain and rough winds made it even more difficult. Those slippery rocks also posed a risk. A slip, and builders would end directly in the chilly North Atlantic. The construction crew also had to use their mountaineering skills. Finishing the lighthouse meant they had to improvise with a human pyramid. One person on its knees, another on top, and a third on top of them. Point Nemo translates to the point with no man. It's the location in the ocean that's furthest away from any piece of land, over 1,600 miles away. It's a sad zone when it comes to wildlife too. This area in the South Pacific Ocean is vast, about 34 times the size of France. But marine life can't thrive here because of the lazy ocean currents. They can't bring enough nutrients for bigger sea creatures to survive. Scientists were only able to see some bacteria and small crabs in those volcanic vents at the seafloor. Point Nemo was first pinpointed in 1992, but it hasn't been explored much since. Sailors aren't even the closest people to Point Nemo. They're the astronauts that cruise above it in the International Space Station. Because it's mostly barren, astronauts have often used it in their exploration projects. When spacecrafts are ready to retire, this is where they're laid to rest. It's the best place to avoid land damage by having devices plunge into the Pacific. Over the years, Point Nemo's become a resting place for all sorts of space machines, over 250 of them. In 1997, Point Nemo also became the source of an unusual sound heard by marine scientists called the bloop. While people were initially excited to link the weird noise with some undiscovered and dangerous ocean creature, it was soon learned that the sound was made by an ice quake underwater. Can people go through Point Nemo? Not anytime soon. The exact location of this spot was calculated using special software to solve the challenge of the longest swim. The goal was to show the spot in the global ocean where, if someone falls off a ship, they'd be the farthest from any land in every direction. It's possible that no one has passed through these exact coordinates at all. No commercial or touristic ships are known to pass through. The Hronci Abyss is located in the Czech Republic, and it's the deepest flooded pit cave in the world, measuring over 1,700 feet. Scientists have yet to identify how far it reaches into the ground. It also didn't form as most pits do, from the surface of the Earth making way down. This one made its way up due to lukewarm mineral water filled with carbon dioxide. This fizzy concoction emerged from deep within the ground and chiseled away at the limestone. At some point in its history, the ceiling gave in, unveiling this huge hole to the world. It's not just the depth that makes it difficult to explore. It's the liquid itself. It can cause problems since it has a high carbon dioxide content, enough to tickle a diver's exposed parts. This water's unique blend even influences the type of gear one can wear. Opt for open-circuit scuba, and the exhaled bubbles set off a chemical reaction. The result means less visibility in a place with low light conditions. You might think falling into a black hole is as easy as falling into a giant pit, but boy, is it a whole different ballgame. To actually fall into a black hole, you would need some incredible luck and a dash of wizardry. Moreover, if you were watching something fall into a black hole, you wouldn't even see it. Why? Well, let's try to understand the magic of physics. Falling into a black hole is really tricky. First of all, to even have a chance of doing this, you would need to aim perfectly and start your journey from very far away. It's like trying to hit a tiny target from a long distance. That's because black holes exist within galaxies, which are filled with other objects like stars, planets, and gas clouds. These objects have their own gravitational forces that can influence the path you need to take. It's like you have to carefully navigate through the room, avoiding bumping into others or getting pulled off course by their movements. In a similar way, when falling into a black hole, you need to navigate through the influences of other celestial objects. As you get closer, things get even more complicated. Making even the tiniest change in direction would require a tremendous amount of energy that you wouldn't be able to generate. It's like trying to steer a spaceship with no fuel left. This is because the black hole's gravitational pull is immensely strong. Once you pass the point called the event horizon, there's no coming back. You wouldn't be able to control anything. Now, even if you somehow manage to get on the right path and avoid all the obstacles, there's still a dangerous situation waiting for you. The intense heat and energy around the black hole, called plasma, would fry you as you get closer. So, you would need some impossibly strong protection to get even close to it. But not only is it nearly impossible to fall into a black hole, it's also impossible to see someone falling in it. Why? Let's find out. Imagine you're standing far away from a black hole, watching something getting closer and closer to the event horizon. As this thing, let's say it's a spaceship, falls into the black hole, two very strange things start happening. First, the color of the spaceship will change. You see, the gravity near a black hole is incredibly strong, much stronger than anything we experience here on Earth. This intense gravity affects everything around it, including light. Now, light has this fascinating property where it carries energy. But when light gets close to a black hole, the powerful gravitational pull starts sapping away its energy, kinda like stealing it, making light weaker. And you know how when you look at a beautiful sunset, the sun appears to be this warm, reddish-orange color? Well, that's because when sunlight travels through our atmosphere, it scatters and loses some of its higher energy bluish colors, leaving behind the redder ones. So when light loses energy, it tends to shift towards the red end of the color spectrum. The same thing happens near a black hole. The light from the spaceship loses energy due to the black hole's strong gravity. So, the spaceship, which initially had its own color, starts looking redder and redder as it gets closer to the black hole. It's as if the black hole is casting its magical spell, changing the color of the spaceship itself. The second weird thing is related to time. According to a theory of general relativity, gravity can mess around with time itself. And it works in a very strange way, because none of you, not people on board a spaceship, will feel this change. For you, an observer in this scenario, time is flowing just like it always does. You're just sitting there, sipping your space lemonade and watching the spaceship's journey. For people on a spaceship, things are the same. Their watch ticks away at a regular pace, and they go about their day as usual. But, objectively, for you, it would be like watching a spaceship fall in slow motion. It will seem to you that it's been falling into a black hole for weeks or even years. You might turn 80 and the spaceship is still out there. Crazy, right? Now, if time slows down for the spaceship, it means the light it emits also slows down. So, imagine someone on that spaceship flicking a flashlight on and off. But because time is moving so slowly, the light coming from the flashlight also moves in slow motion. It takes ages for each burst of light to reach your eyes. You'll be watching a spaceship as if you're watching a video in super slow motion. And when light takes longer to reach your eyes, it becomes weaker and dimmer, just like a fading star. So, as the spaceship gets closer and closer to the black hole's event horizon, not only does it start looking redder, but it also appears dimmer. So it becomes harder and harder to see the spaceship as it gets closer to the black hole. it slowly fades away, like a disappearing act on the grandest stage of the universe. Pretty mind-boggling, isn't it? But that's all about you, the observer. And how are people on board doing? What do you actually experience when you fall into a black hole? As you get closer to the black hole, something really weird starts happening. The gravity near the black hole is so powerful that it stretches and warps everything around it. So the difference in gravitational pull between your head and feet becomes significant. This difference creates a tidal force, which stretches your body like a long, thin shape. It's a process that's scientifically called spaghettification. Essentially, you would be stretched into a human noodle. Being turned into spaghetti might sound fun for a pasta lover, but it's definitely not so great for an astronaut. Meanwhile, colors around you begin to warp and distort, creating a dazzling light show. It's like riding a roller coaster through a rainbow tunnel. Twists and turns, flashes and sparks. It's an exhilarating, mind-bending experience. And then, what happens to you depends on the type of black hole. First, we have classical black holes. These are black holes that exist forever. If you fall into this black hole, it would take an incredibly long time to reach the center. The center would keep getting closer and closer, but you would need an almost infinite amount of time to reach it. So it would feel like your journey would never end. And then we have evaporating black holes. These black holes can evaporate over time due to a process called Hawking radiation. It's just like the ice cubes melting away. These black holes have a limited lifespan, and it's basically impossible to fall into one of them. As you approach the evaporating black hole, you find yourself hovering near its edge, the event horizon. It's like being stuck at the entrance of a super cool amusement park. But guess what? This amusement park is shrinking. The black hole is evaporating, and as it does, the event horizon gets smaller and smaller. So you stay right at the edge, tracking its every move, but you will forever stay in this event horizon without ever crossing it. But remember, once you pass the point of no return, there's no way back. You're on a one-way ticket to the mysterious heart of the black hole, the singularity. At the singularity, everything goes bonkers. Our current understanding of physics goes haywire, so it's a bit like entering a magic show. What happens once you reach the singularity? Is there anything on the other side of a black hole? We have no idea. It's a big mystery for us, but maybe we'll figure this out someday. So, my friend, it's best to admire black holes from a safe distance and let your imagination soar with the incredible wonders they hold. Just remember to keep your pasta on your plate and not near these cosmic spaghetti makers.